In this video, I'm so excited to introduce this significant feature delivered from Siemens that allows the Siemens S7-1200 PLC and S7-1500 PLC to implement as EtherNet IP scanner the master controller function. As we know, the standard field bus from Siemens, that is the PerfectNet, and the PLC can run the PerfectNet master and can communicate with PerfectNet devices. The EtherNet IP field bus are mainly supported by Allen Bradley and widely used in North American area. In the past, if you have an EtherNet IP devices need to be communicate, but the controller, that's the Siemens controller PLC, S7-1200 or S7-1500 PLC, because of the EtherNet IP protocol, Siemens didn't support that, so they cannot communicate each other. Also, if you have a Siemens and Allen Bradley system, you need to communicate them together. Basically, alternative way, you have to use maybe the Modbus TCP. They cannot use PerfectNet or Ethernet IP to communicate each other. This is in the past, but now Siemens released the feature allows the Siemens controller can run as Ethernet IP scanner or even adapter the devices. And in this case, I would like to introduce this feature that allows the Siemens controller can run as Ethernet IP scanner the master. So the Siemens controller can communicate with Ethernet IP devices adapters. For example, in this video, I will show how can we use the Ethernet IP devices and use the Siemens S7-1200 PLC to communicate with this Ethernet IP adapter the devices. And totally the solutions or examples from Siemens, they released 4 examples that basically allows the Siemens can run as the Ethernet IP scanner and adapters. These are 2 examples. Another 2 features the Siemens can run, that's the CIP server and the client. I used one video shows this feature before that allows the Siemens can run as a CIP client, and Allen Bradley CompactLogix or CompactLogix can run as a CIP server. So in this example, this can used for the case if you have an Allen Bradley controller, for example CompactLogix or ControlLogix. Basically, at the Allen Bradley side, you do not need to do anything. The client side, the Siemens side, they can use this function block LCCF CIP client. So you can type in the variable, the name. Those names that directly come from the Allen Bradley side, the variable name. So the Siemens side can directly read or write the variables and exchange the data between the Allen Bradley controller and the Siemens controller. So this is the CIP client role. And in this case, I will introduce Siemens controller running as a master. This fit for the scenario. For example, in this picture, my controller, this is a 1500 or 1200 controller, and the main system, this is a PerfectNet system, Siemens ET200 SP or other PerfectNet devices. But maybe you have one devices, for example, barcode scanner, printer, heater, or some other VFD devices. They could be Ethernet IP devices. So how you can communicate with them? In the past, Siemens controllers cannot directly communicate with them, unless you are using some bridge from PerfectNet communication to Ethernet IP communication. But now, using the feature today I'm going to introduce, you can communicate with them. This is really a feature revolution from Siemens side. I'm so happy to introduce this example. Let me show how can we download this example, and I will use my demo system and real hardware to introduce how can we use the 1200 PLC TIA portal system and communicate with this Ethernet IP adapter devices. Okay, let's go. All right, let's go to support.industry.siemens.com, and then let's search this number 1097823114, and you will find this example Ethernet IP scanner connecting certain I/O using Ethernet IP. So this application allows the S7-1200 and S7-1500 PLC to run as Ethernet IP scanner. Basically, we could call Ethernet master, run the similar role as Allen Bradley CPU. And from the bottom here, you will see the document and the example projects. It has version 17, 16, and version 15.1. And other than this example allows the CPU running as an Ethernet master, it actually has this example Ethernet IP adapter. This example allows the Siemens S7-1500 and 1200 PLC running as an Ethernet IP adapter. Basically, the role will be flipped. So the Siemens controller can run as Ethernet IP devices, the adapter role. And I will show another video show how can we implement this. Okay, let's download the library and let's download the document. And there are some important notes I like to mention. Okay, this is the manual for 1097A2.314 running the Ethernet IP scanner, the master function. I highly recommend you read this manual page by page. It totally has 45 pages. It won't be too long. You better go through entirely. And there are a couple important notes I like to mention. Firstly, let's go to the 40. So at the page 41, when we use this function to add on the Ethernet IP function for the CPU, definitely we will import one large function block. So how large this function will be? So here it shows the size of the work memory take in the CPU. So for the 1500 and the 1200 PLC, it won't be too small, especially for the 1200 PLC. Basically, once we use this function, for the 1214 PLC, it will take 40% work memory and the load memory already. You need to estimate the work memory and the workload for your CPU. Okay, and this is a very important value here. So for the 1500 PLC, the maximum there are 16 Ethernet IP adapters can be controlled. For the 1200 PLC, the maximum device, that's the 8 adapters. And this value actually comes from the OUC resources from the CPU. It simultaneously can communicate multiple devices, but keep in mind this is the number. For the 1200, that's the 8. For the 1500, that's the 16. And this is the size. Another thing, this is the cycle time. So this list shows the workload for the CPU. And I highly recommend you watch this technical data, this page. So according to this chart, basically when we implement this function, the cycle time of the scanner to scan the Ethernet IP adapters or devices, I would recommend the time could be larger than 10 milliseconds. I would recommend set 20 or even higher to 30. Okay, another question, how many bytes allows the scanner or allows the Siemens CPU to communicate with one device? That's the data, the 496 bytes. So please notice here the maximum size of the 496 bytes. This is the limitation from this standard, from the Ethernet IP. So just to keep in mind, I never saw any devices that data need higher than even 400 bytes. Basically 20 bytes or 30 bytes, that's enough. This is the typical case. So you do not need to worry about this. Just to keep in mind, there's one limitation at here. This comes from the Ethernet IP protocol itself. Okay, the last things I like to mention, that is the last page. The last page. According to my test, please read this word here. So what the next? This is basically the next plan or something this example can be improved. The first thing, this is the support for the modular adapters. Okay, keep in mind this. This is true. According to my test, if you have some devices that directly you can read from their web page showing the assembly numbers, input and output assembly numbers. For example, the typical input assembly number will be 101 or 100. They won't be modularized. They basically one module, for example, the VFD or some heater or some scanners. It doesn't have any other like a chassis behind. For those Ethernet IP devices, that assembly number, input, output, and configure number, assembly ID can be easily read out. So the Siemens, this example can communicate with them, basically no any issues. But however, if you have the chassis style and the multiple modularized style, for example, the typical style, this is the .io of Allen Bradley. They have a chassis and a multiple modular at the right side. In this case, especially in their website, you can now read out the assembly number, input and output. If you have those Ethernet IP devices need to communicate, I will not recommend you use this example, use the Siemens as the Ethernet IP master to communicate with those devices. because it's really hard to figure out the assembly number input and output. I didn't do the communication successfully using this example to communicate with Allen Bradley port I/O because this is a modular adapter. So if you have any chances to test this Siemens Ethernet IP master example to communicate with Allen Bradley port I/O successfully, please let me know. Alright, let's shift to the TI portal and I will follow this manual procedure to implement Siemens controller as the Ethernet IP master and communicate with Ethernet IP device. This is this I/O device. This is the TI portal project, and currently I'm using version 17, this version. So the library I need to import, I download from the website I just showed. I need to download version 17. Okay, and the current job, if we go to the hardware, I'm using 1200 PLC, and this controller, this is CPU 1214C. Okay, if we go to the network wheel, we will see, and this is the ET200SP Siemens I/O device. Their communication, that is a perfect night I/O communication. And now this communication I set up and I download successfully. If we go to online, we will see this controller is communicating with this device, perfect night device. Okay, we will see everywhere they are green, and this device is communicating. This is the case I especially want to show. Other than communicating the perfect night, this port can still implement this Ethernet IP function, allows this CPU control the perfect night devices. At the meantime, it can also control the Ethernet IP devices adapters. Okay, now let me go to the offline, and firstly, we need to import the library. Okay, the library I download, this is the library. We will see the type. This is the compressed library, LCCF Ethernet scanner. Okay, and then let's go to the right side, go to the library, and click this Open Global Library. Okay, let's go to this folder and go to this library folder, version 17. Make sure you are using the correct version. And that's because it's going to open the global library, but the current file, that's the compressed file. So we need to select this compressed library. Okay, so it show up. Let's click and open. So once we click the open, it will firstly ask you to select one directory to deploy this library, to unzip this library. Okay, we will unzip this library at here, select the folder. So current folder, we only has this compressed file. Okay, and now I'm going to select this folder, and we will see one library are deployed here, and we will see this library project. Okay, now we opened this library. Okay, and its status shows green. No problem. Okay, in this case, I'm using 1200, and as we can see, for the 1200 and the 1500, their library, they're quite similar. So using 1200 and 1500, they're almost the same. Okay, in this case, I'm using 1200, 1214. Okay, then go to the left side. Firstly, let's drag something for the PLC date types. So date types, let's drag these date types to here. Okay. All right, we drag these date types. In this case, we need 3 date types. Basically, these 2. They are very important. And then let's drag this function block. This function block is the most important thing. Okay, let's drag this function block to the program blocks. Okay, it show up this example. So by default, it will be coordinated with the library structure. Okay, we click OK. All right, so this is the important function block. This will run, allows the CPU running as an Ethernet IP master, the scanner. Okay, and then to call this function block, we need to use the cyclic, because the function block, it only has the enable function, but definitely the Ethernet IP, we need a cycle time to call this communication, right? So we need to add a new block. Default, this is the OB1. OB1 is just a free scan itself, right? We need a cyclic call. So let's click this organization block to call the Ethernet IP devices as a 10 milliseconds as a cyclic time. So we can set this cyclic interrupt as a 10 milliseconds. Okay, using this name, we roughly know this cyclic interrupt OB, what the properties of this OB. So its cycle time is 10 milliseconds. Okay. Then let's go into this interrupt OB. Then right click, we can create one line here. Okay. At this line, we can call this function block. Okay. Because this is a function block, so it needs one instant dB behind. So I can rename this instant dB number to 2. And okay, we can use this default name. This scan, this EtherNet IP scanner dB. Okay, we can use this default name. Okay, we call this function block and we also add this instant dB. And here we can write this is the EtherNet IP scanner master. Okay. And at here, we will see some parameters at here. More importantly, we will see this adapters and the data. Data, this is the place for exchanging the data with the Ethernet IP devices. And adapters, this is the configuration data. It's similar as the hardware configuration. Then how can we program this? So we need to use the date type at here. Okay, the date type. So we will use the adapter config, this date type, to assign some parameters. And this Ethernet adapter data, this is the date type for the data exchange with Ethernet IP devices. Okay, now let's create one shared DB, one global DB, date block. Okay, this is global DB. And the manual, I can set the manual number to 10. And here I can call, this is a DB for Ethernet IP devices. Okay, this is DB for the Ethernet IP devices. And then once we open this DB, at here we can create the date type. So the date type, we will prepare something specially for this area. Okay, and here we can call, that's the adapter settings. Okay, and the date type, we can name the date type as this. Okay, adapter config. But we know Ethernet IP could have multiple devices, right? So to set for the multiple devices, we can create one array at here. So we can use array. Okay, if we have two devices that start from 0, the length could be the 2, 1. So it starts from 0 to 1. So we could set the array length like this. So the off, after this off, this is the date type. So we can type in this date type. The date type, this is the Ethernet adapter config. So we can call LCCF. So we will see it automatically show up. We will pick this Ethernet adapter config. Okay, so after we set this, we will see it generate two arrays elements here from 0 to 1. From 0 to 1. So this means we can configure two devices. And then we can configure the next one. This is the adapter data for here. So we could call this is the Ethernet IP devices data. Okay, and array, we could still set from 0 to 1. We can prepare for two devices. In this case, I will use the Ethernet IP devices as my devices to test. I only have one Ethernet IP device, the Moore device, but I can still prepare two, one used as a spare. Okay, here, the data, we will select the LCCF. We will select this Ethernet adapter data. Okay, so it will generate two elements in this array. Okay, so we configure this. Then we will drag this adapter setting. This is this date type. Watch out here. Drag to here. Okay, and for the data, we can drag to here. Okay, and then we can configure the input and the output. Okay, for example, the enable. Okay, I can configure the one M address. And the interface, this is very important. So how can we configure the interface? Okay, the interface, let's go to the device config. And this is the CPU hardware configuration, right? So if we go to the properties of this controller page, properties, and from here, the system constants. And here we will see the port, this Ethernet port, it has one hardware ID number, it named 64. This is the hex number. That decimal number, that's 100. Okay? We will tell the function block we are going to use this interface. So this is 64. Then let's go back. So at this interface here, we can click this button to select that port. So the port we are going to use is this local PerfectNet interface. Okay, once we click select, so the number that's 64. Okay. And at the right side, we can assign some variables at here so we can read the status from this function block. It's easy for troubleshoot and monitor the status. So I can assign some variable. I prepared some variable. That's why I can config quickly. So watch out. So take care here. This status, that's the word. Okay. So we can read the error code. So that status, this variable, we need to assign one word. So here I'm using MW10. Okay, so we assign everything here. So this is the basic function block code. Okay, and according to the manual, the next things we need to assign the parameter in this DB. Because this DB, this setting here, we need to set some parameter. Tell this function block, okay, this is the IP address, the target IP address I'm going to communicate. And there are some Ethernet IP device configuration. So in this case, I'm going to use the more Impact 20. This module, this is the Ethernet IP device. It has 8 input and 8 output. And this is the typical device I can use as an example. For example, they could be Ethernet IP, heaters, VFD, barcode reader, or scanners. That device, they are not modularized, or even some modularized device, as long as it has a web page and you can see the assembly number, input, output, and the config assembly number, is still fine. So I'm going to use this device as an example. And from this device, as we can see, so this is the CPU 1200 PLC is communicating with this ET200 SP. The communication between them, they are PerfectNet I/O. And at here, I have this device. Its IP address is 192.168.1.193. So this is the Ethernet IP device. Okay, so in this case, this CPU will run as Ethernet IP master, the scanner function, and connect this device. And currently, this device is not communicating with this CPU, so it's losing the controller. That's why this indicator, network indicator, is blinking here. And this is the input indicator. I'm connecting the 24 watt to this input. And these two lines, they are output, because now it doesn't have any CPU communicating with this device now. So the output is nothing. And this is the Allen Bradley point.io device. Frankly speaking, I didn't do this communication successfully using Siemens CPU as an Ethernet IP master to communicate with this device. That's because this point.io, this is the modularized, and this chassis is a little bit hard to configure. If you go to the website of the point.io, I can now find the assembly number, input, output, and config number from the point.io webpage. So this is really hard to figure out what the parameter, especially if this chassis based. In the contrary, if you have the standalone module like the Moore module or VFD or heaters or some other devices, basically this is the one device. And they supply the Eds file, and they also have a built-in web page. And once you open the web page, you can clearly see the assembly number, input, output, and config number, ID number. So in that case, it will be very easy to configure those numbers in the Siemens that function block. I will show the parameter configuration very soon. Okay, let me go to the Moore website and let me show how can we download the Eds file. Using the EDS file, we can see some parameter and we can mimic this parameter, copy and paste into the setting data block. Okay, this is the Moore website. So this is the 8 input, 8 output. So this device support Ethernet IP. And then let's go to the download. And from here, we can search the EDS file. So this EDS file is here. And we can download this EDS file. For this case, using Siemens CPU running as Ethernet IP master, I highly recommend the devices you are communicating, you better have the EDS file because we can see a lot of parameter from the EDS file. It's very straightforward to set those parameters into the DataDB. Otherwise, if you need to manually set the input-output assembly number, that's quite difficult. This is my personal experience shared from here. Okay. And now I download this EDS file. If I right-click, if I open it via the notepad, so we can see those are parameters for this Ethernet IP devices. Okay, at the right side here, if we are going to use the index 0 for setting this device, we need to follow this sequence to set something according to the values from this EDS file. Okay, so firstly, let's set up the IP address from this Moore device. So to set this value, I highly recommend we can write some program at here, write the value directly to this address. So we can use the move command. So we will set the IP address. So we can drag this address 1 and address 2, address 3, and address 4. Okay, so the IP address of this Moore device, this is the 192.168.1.1.193. Here, we set the IP. Definitely this IP address, the subnet need to be the same as the CPU. So in this case, if I go to the hardware configuration, network, so the CPU now, the CPU IP address is 1.181, okay, and this ET200SP IP address is 1.182. So this Moore device, this is 1.193. Okay, this is their IP address. And to implement this Ethernet IP function, we do not need to set any hardware setting. All the function we set here, they all programming wise. We do not need to set any hardware setting for this case. Okay. Okay, this is the IP address. So we can write this IP address, those values directly to here. And then let's find this vendor ID, product type, and the product code. So if we have an EDS file for this 56917, this impact 20 Moore device. So the vendor code, product type, and the product code, they are quite straight. Okay, they're all here. So we can manually type in here. So this vendor ID, this is a 6040, and the product type, this is 7, and product code, that's the 56917. Okay, we can write this value here. So you will see in the Siemens example, they are writing some parameter at here. Personally, I like to write the value in the program so we can monitor and watch those parameters in one glance. Right? If you write some parameter here, you have to open the DB to watch the parameter you set. But if you are going to use the program to write, so you can easy to troubleshoot and review the setting you did. Okay, so I'm going to write something here. I will drag this vendor ID. This is 640. And the next one, the product type. So the product type, this is 7. The product code, this is a 56917. I copy and paste here. Okay, we finish this 3 parameter here. And then let's say this is a parameter for the revision, major and the minor. Okay, major and the minor we can see they all 1. Okay, then I can copy and using move. This is the major and the minor revision. And then the more important values from here, the assembly number, output size, input, and the input size. So they are very important. So how can we set this? If you have some background knowledge from the Allen Bradley Studio 5000, you can recall when you set some devices, especially that device doesn't have the Eds file, you probably need to set the input, output, and the config assembly ID. Here, I highly recommend you go back to the menu, and in the menu, it explains very detailed on those parameters. How can we translate the assembly input, output, configuration number using the data at the very bottom line, those data. And personally, I would recommend we can go to the web page of this Ethernet IP device, and we can see the assembly number input output value directly from the web page. Let's go to the Moore device, the web page. So I can search 192.168.1.193. Okay, so we can browse this device. And here we can see this is my IP address setting for this module. And from this home page right here, it shows this is the 8 input and 8 output module. And from here, we can directly read the input, output, and config the ID number 100, 112, and 128. And especially, it also shows the size. So the input, I need to set the size as a 3. Because other than the standard signal, it also comes with some diagnostic variable behind. Output, it only has 1 byte. Okay, the configuration, that's the 0. So the web page can directly tell us those settings. It's very convenient. Most of the cases, I would say 90% of the Ethernet IP device, they all has the built-in the web page. You can reference those variables. You do not need to manually calculate these things, especially manually calculate or translate some parameter at this area. Okay, you can read from here or go to the web page. So for this case, let's set some parameter at here. And the same thing, I like to list the value at here. So let's still use the move. Okay, so let's firstly set the input. So for the input is here, the input ID and the input size. Okay, the input, this is the 100. And the input size, this is 3. Okay, and for the output ID is here. The output ID, that's the 112. Okay, 112 at here. And output, it only has 1 byte. Okay, and output size. Okay, this is the size, and this is the assembly number ID. And then the configuration. Okay, so this assembly instant. Okay, the instant configuration, that's the 128. Okay, and the size is here, config date size, and that's 0. Okay, so those parameters, input 100, output 112, and the config, that's 128. And input, it has 3 bytes. Okay, 1 byte for output and 0 for the configuration. If we go to the web page review again, 100, 112, and 128, 310 for the size. Okay. All right, we set everything. So, and the last thing is this package interval, the cyclic interrupt, that's the 10 milliseconds. So we could set 10 milliseconds for this device. Okay, so we set 10 milliseconds, T, POM, 10 milliseconds. I would recommend you set this RPI cycle time as 20 milliseconds or above 20 milliseconds. Here, 10 milliseconds is used to some special test. Okay, we went through all the parameters. We better go to the web page, check out those values. Okay, those values, basically, they all come from the Eds file. And the last things we set the cycle time. Okay, we config everything for this Moore device. And now we are able to download. Okay, we leave the number 1, this devices as a spare. So in case you have multiple devices, for example, if you have a totally 6 devices, you will set from 0 to 5. It starts from the 0. If I have a totally 6, you will set 0 to 5. And now we can compile and download. And from this OB1, it has nothing. That's because this cyclic interrupt is calling everything. It mainly call this function block. And this is the parameter for this station. So from here, we can, okay, this is the parameter for the device 0, which is more 192.168.1.193. Okay, this is the more 8DI, 8DO digital input and 8 digital output module. So we will know those parameters are used for setting this device. Okay, and now we can compile and download. Okay, after we download, and then let's go online. And let's firstly verify the parameters in the DB. And let's go to the adapter setting. And let's click the online. So as we can see, all the parameters are showing on this monitor value. This is the real value in the DB data block. So this is the IP address. And this is the hex value showing here. And all those settings are the same as we set before. Okay. And after we verify the parameters, because all the parameters come from this area here, and this is also a good place for us to have a glance to verify, especially if sometimes the input output that got backward. Okay, so this is easy to review. And now we can enable this communication. In the meantime, we can watch this output status. And busy on, valid on, that means parameter are set correctly. And let's wait for a while. And after a couple of seconds, we will see this is active, is on. That means the master and the slave, they are communicating successfully. And now we can go to the data. And let's firstly verify the input. Okay, so we will see the value is showing 2. That's because that is starting from the bit 0. But now the bit 1, that's the on. That's why the integer value, that's the 2. I unplug this second channel and plug to the channel 0. So we will see plug into the channel 0. So we will see the value is showing 1. If I unplug and plug to 02, that is the third bit, bit 0, bit 1, bit 2, the third bit. Okay, 02, the value is showing 4. So that means now our master is communicating with this device and can read the real input. And now let's test the output. Let's shrink here. And let's go to the output 0. So we only have 1 byte, right? So if I set 5 at here, right click, click this modify, write 5. Okay, let's set as a bin. Okay, the 5, that's the 1010, right? 1010. So we will see the output 1010 is on from this output. Okay, if I change the value to 9, so that bin value is 1001. Okay, we will see 1001. So we will see that's the 1001 output. So we will see this is the 1001 output. Okay, so that means we can control this output. They are communicating correctly now. And if now I go here, this is the true signal I can control. If I set are always on, for example, I can set true directly and download. So let's do a test. If I set true here, give always on. After I download, if I cycle power, and let's see if this communication can recover by themselves. Okay, I download the program, and now let's cycle power. And because I set a true to the enable, ideally, once we cycle power, the controller, once it starts up, it should enable the Ethernet IP communication, and the Ethernet IP communication right here should automatically recover. And let's see what it will be. Turn on. In the meantime, let me click this online. And let's watch this output, especially for this is active feedback. Okay, we will see this communication recovered very quick. Basically, after the reboot, it automatically recovered. And also we will see this enable is always true and this active is true. And code number 7002, this is the correct code. And valid busy, they all true. That means it's communicating correctly. Okay, in the meantime, let's go to the CPU and let's watch the CPU processing time. And let's click this cycle time. So we'll see, I set 10 milliseconds, okay? And its processing time now is 5 milliseconds, this workload, okay? And also, let's go to the program info. And as we can see here, the actual size of the function block for the work memory and the load memory is taking 40K and 55K respectively. So this could be a reference for you to implement this function for your existing system. For example, if your controller, that's a 1500, that won't be a big issue because 1500 basically their work memory and the load memory, they are very big. But for the small controller, for example, for the 1214 or even for S7-1200, that controller CPU, the work memory only has 75 KB. That could be an issue if you are using this function block because that controller almost full. And also keep in mind one thing about the controller firmware. So if I go online now, and the firmware of the CPU I'm using, this is firmware version 4.4. According to the manual, for the 1200 PLC, your version must be above version 4.2, starting from the 4.2. And if you are using 1500 PLC, the 1500 PLC firmware version need to be higher or equal to version 2.6. So some old firmware CPU, you probably need to upgrade your firmware to a higher version. So at least need to be above this version. Okay, for the new ordered CPU, 1200 and 1500 PLC, they all should be okay. So again, to implement this Ethernet IP scanner function, we do not need to configure any hardware configuration. So we only need to configure this DB, that adapter setting. And meantime, this CPU is still running as a PerfectNet master, communicating other PerfectNet devices. So this Ethernet port is communicating versatile and can run multiple protocols at the same time because this port can run multiple resources behind. If we go to the CPU, if I double click, and we will see the resources of this CPU setting. And go to the connection resources. So this is the CPU resources, especially for this open user. So we'll see the maximum number, this is 8. That's why to communicate with Ethernet IP devices, so the maximum number from 1200 PLC, that's the 8. Maximum number, that's the 8. That actually using these resources behind, okay? And the config value now is showing 0, just because the method we are using, that's a software way to enable. So this is basically a flexible resources to use the communication resources from this controller. That's why the config resources showing 0. But you need to be very carefully. The maximum resources from this port, that's the 8. And the PerfectNet I/O, that not included in this resources. This is the hardware portion too, so you do not need to worry about these numbers to do some interference or the conflicts with the perfect net communication. The perfect net communication, that resources now belongs to right here. The perfect net is using the dedicated microchip to doing the job, so the resources here, it won't cause trouble for the perfect net. Alright, this is the Siemens S7-1200 and S7-1500 controller running as Ethernet IP scanner, the master function. As I introduced at the early beginning, this is really a feature revolution delivered from Siemens. So at here, I would like to use almost 15 minutes to show this concept and show how I did this example test. And hopefully this video could be helpful for you. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.